overview on solubility and EDD. I highly recommend you use your density test and your density notes in your interactive notebook to study for that, because density will also be a huge part of your Unit 2 test. Okay, let's get started. Definitions in your own word and draw a picture. So a solute is anything or any substance, it's usually a solid, that dissolves. Okay, so a solute is any substance that dissolves. Okay, a solvent is the substance in which a solute dissolves. Okay, so if I'm using coffee and sugar as my example, the coffee would be the solvent and the sugar would be the solute. Solubility is a characteristic property. That means we use this property to help us identify something, an unknown substance. That says like how much of something, and again I'm putting this in my own words, how much of a solute will dissolve at a temperature. So that's solubility. At 20 degrees Celsius, how much of this substance will dissolve? At 80 degrees Celsius, how much will this same substance dissolve? A saturated solution is a solution that can't hold any more solutes. Hold any more solutes. So if a solution is saturated, that means it has a lot of extra solutes that sank to the bottom. A mixture is a combination of two substances, and the key thing to know about mixture is that it does not make a new substance. Okay, and you can usually separate mixtures, and we'll talk more about mixtures later. Okay, it says draw a picture as well. You guys should have drawn a lot of these in your interactive notebook, so you can just draw like over here like a cup with like sugar and water. You can label solute, solvent, and you can draw little dots on the bottom to see that it's fully saturated. Okay, list 3 ways that you can increase the rate of solubility in a solute. Or basically, how can you make the solute or the powder or whatever it is dissolve faster? And use the pictures to help you out. So if I had sugar and I wanted to dissolve it faster in water, there are 3 things I can do to that sugar. I can increase the temperature, and we did that in a lot of these labs, especially the virtual one. If you increase the temperature, the rate of solubility increase. So that's this picture. Okay, and this one, what is this cup? What is this spoon doing? It's stirring. So when you stir something, you also increase the rate of solubility. You make it dissolve faster when you stir it. Okay, and that's also sometimes called agitation. But you can just know that it's stirring. And the last one, which we'll talk about in question 3, is you can increase the surface area. And we'll talk more about that one with question number 3. Okay? But you need to know, if I wanted to make something dissolve faster, these are the 3 things I can do if I want to make the solubility increase, or the rate of solubility. Question 3. Which has more surface area? A cube of sugar or grains of sugar? And this is like a like each one of these little cubes is like 1 grain of sugar. So if you're looking at this, I know right away you might think, okay, this is bigger, so it has more surface area. The thing is, surface area, if you remember in math class, if I was doing this cube right here, surface area is, if I were to undo this cube, right, Is that enough? No, that's only the four corners, so I need another one to top the cube. This is surface area. Surface area means if I make it like flat, what is the most amount of space it takes up? Okay, so thinking about this, which one would have more surface area? This one big cube of sugar that looks like this when I sort of unravel it, or grains of sugar, and each one of these will unravel into this. So which one's more? Having it like this, like one cube of sugar, or having this, but because these are grains of sugar, this is going to be like, I don't know, 2 million, grains of sugar. So when you think about it, you have way more grains of sugar and have more surface area than you do with 1 cube of sugar, right? So which one has more surface area? It's going to be the grains of sugar, or the sugar powder, okay? Because if I have all of these individual, each of these represents 1 grain of sugar, right? And if we were to get each one of these little grains and unravel it, we would see that obviously this would have more surface area. Okay. Which will dissolve faster in water? This cube of sugar or the sugar powder? Explain why. Hopefully you'll realize that if I have grains of sugar, they're going to dissolve faster. And the reason behind that is because this has more surface area. So if it has more surface area, the solubility will increase. It will dissolve faster. So the grains of sugar will dissolve faster, and it asks you to explain why. Because they have more surface area. Okay, and let's go back to question 2. What are some ways we can increase how fast something dissolves? You increase the surface area. So let's go back to question 3. This will dissolve faster because it has more surface area. Okay, so you have to know that. Don't get tripped on, oh, this is bigger, so it has more surface area, so it's going to dissolve faster. No, that's not the case. Explain how you would separate a mixture of salt and water. So if I have some water and in here I have salt, how would I get that salt out of the water? The way you would do this is by evaporation. Okay, hopefully you remember this in 7th and 6th grade science when we're talking about like the water cycle. If you evaporate the water, okay, that means you add heat to it and the water will disappear, okay, and all you have left is just the salt on the bottom, okay? Which is not a mixture? Sugar, C6H12O6, or a solid? Explain. All right, and the answer to this one is sugar. Okay, sugar is not a mixture because it does not combine 2 or more substances. All right, it's just a chemical formula. And again, like if I were to, it does not combine substances and make something new. Okay. So sugar, we have C6H12O6. That's not a mixture. That's just 3 different atoms combining. And if you were to have like carbon atoms, hydrogen atoms, oxygen atoms, and you combine them, you are making something new, right? So that's not a mixture. A solid is a mixture. Explain what would happen to a saturated solution when more solute is added to it. So if something is already saturated, that means it can't hold any more solutes, as we said. So what will happen if you add more solute? Solutes will sink to the bottom. And we saw that in the solutes will sink to the bottom. We saw that in the Glencoe online lab that we did. Describe two physical properties of salt and sugar. Remember, our physical properties are like things we can see with our eyes. So color, texture, things you can touch, like texture and hardness, magnetism, all right? So salt and sugar, you can say they're both white. You can say they're odorless. I don't think they have an odor. You can say I would say they're smooth. Okay, well it says 2, so we don't need to put more than 2. Okay, but those are our physical properties. True or false? Observing physical properties, like texture or odor, of a material would change the material into something new. Okay, let's go back to this one. If I have some salt in front of me and I'm saying, okay, the salt is white. When I say that, did that change the salt into something new? No. So this is false, so you can just circle false. And then you can say, you have to correct it. Physical properties, I'm just going to write physical prop, do not change materials into something new. Physical properties are just things you can observe with your naked eye. Later on, we're going to talk about chemical properties, and that's the one that changes things into something new. But let's focus on just physical. Right now, just physical properties, all you need to know is, oop, I wrote something naked. Awkward. Something new, because I said naked eye. Okay, that was funny. Now you're awake, and I don't feel like making this video again. So, what characteristic property, what is a characteristic property that you can use to identify if a white powder is salt or sugar? So you need to know that a characteristic property helps us identify a substance that we don't know what it is. Okay? So if I have a white powder, am I going to be able to tell if that's sugar or salt? No, because color is not a characteristic property. How about odor? No, because I can't tell if it's sugar or salt just by smelling it. I can't tell if it's sugar or salt just by touching it with the texture. So the characteristic property that we use to ID it is solubility. We say solubility is a characteristic property because it helps us identify an unknown substance. Alright, a little bit of a review. If I have two like rods, right? Remember that lab where we did rods, like those little sticks? Oh, light turned off, sorry. How can what characteristic property can I use to identify if these like brownish rods are copper or if they're brass? Mass, magnetism, hardness, and density. You could use mass, but mass is not a characteristic property. You can't tell if it's copper or brass just because it weighs, or excuse me, it has more or less mass. So remember, density is the characteristic property that helps us identify a lot of unknown substances. All right? And you can review your density notes to help you with that. All right, I know you love these. Solubility graphs. You need to know how to read this. The way you read this is, on this graph you have 1, 2, 3, 4 different solutes. These are all like white powders, okay? If I had 4 of these white powders in front of you, we could not tell what they are. But if I dissolve each of them in water and see how much of it dissolves at different temperatures, then I can be like, oh, this is NaCl. Oh, this is KBr. So the way you read this is, let's do this line. This is KNO3. This is potassium nitrate, KNO3. The way you read this is, at 20 degrees Celsius, about 38 grams of KBr dissolves. That means, at this temperature, no more than about 38 grams of KNO3 will dissolve. All right? Let's do 40 degrees Celsius. At 40 degrees Celsius, no more than 80 grams of KNO3 solute will dissolve. If I put like 100 grams in there, about 20 will fall to the bottom because I know just by looking at this graph, it can't hold more than 80. Let's do NaClO3. That's like another type of solute. At 20 degrees Celsius, about, what number is that? 110 grams will dissolve. So you need to know that this side, the x-axis, will tell you the temperature. So if they say something with temperature, you're looking over here. On this side, the y-axis, it tells you the solubility, or how many grams of the solute will dissolve. Is it 20 grams, 120 grams, 200 grams? All right. Let's do some of these questions together. Okay? Once you get the hang of it, I promise you it is not that hard. Okay? So, how much solute will dissolve at 105 degrees for KBr? All right? So, let's look at this. You have to kind of pay attention to this. So, this is 20. That means if I have 4 here, this is counting by 5. So, it's 0, 5, 10, 15, 20, right? 25, 30, 35, 40. So, this is asking us for 105 degrees Celsius. So, let me make this a little bigger. All right. Okay, so it's asking us how much solute will dissolve at 105. So here's 100, right? I need 105. So I'm looking over here. Which line am I looking at? I'm looking at the KBr line. So I know this is crazy, but you just need to focus on the one they're asking you for. So KBr, I'm just going to color that orange just because I like to color code it. So I'm only looking at this line, all right? So, how much KBr solute will dissolve at 105 degrees for KBr? Again, I go here. This is 105. 105 degrees Celsius is right here. How much KBr will dissolve? The line is right here. Okay, so I need to see how many grams is that. The grams is on this side of the graph. So just get your finger and just kind of la-di-la-di-la. It's right over here. So it's right between 100 and 110. So at 105 degrees Celsius, about 110 grams of KBr will dissolve. So I'm going to write 110 grams. All right? That's what you have to do. Look at what temperature they're doing. Find it on your x-axis. Look at what solute they're talking about. Find the solute line, KBr. And then see how many grams of solute by matching it up to your y-axis. Your y-axis tells you the grams. Okay. Compared to KBr, how much more solute will dissolve for KNO3 at 65 degrees Celsius? Okay. So now it's asking us to tell me the difference in solubility between two of these lines. So first thing I'm going to do, 65 degrees Celsius. I'm going to look over here. This is 65 degrees Celsius. That's where I'm looking at. I'm looking at this line over here. It's asking me how much more KNO3 will dissolve than KBr. So let me color my KNO3 line, because now I need to pay attention to two lines, right? This can get tricky, I know, but take your time, pay attention to your lines, and you'll get this. All right? So I'm looking at KNO3 and KBr. So how many grams of KNO3 would dissolve at 65 degrees? At 65 degrees, KNO3 will dissolve, boom, right there. And again, these don't have to be exact. I just need to know that you know how to like find this. So it's kind of like in the middle of these. So that's going to be 100 and I would say, should have done this before. Well, I would say 145 because it's right between those two lines. If you get a different answer, that's fine. So 145, and that's for KNO3, all right, at 65 degrees. While how much KBr will dissolve at that same temperature? So I'm going to do the same thing. Find 65 degrees. Now I need to see how much KBr will dissolve. Right here. And I'm going to match this to how many grams. This is a nice easy one. Oops, I just lost my line. KBr, 65 degrees. It's okay if you want to start over. Right there. Boom. and I want to see how many grams will dissolve at this temperature. Right here, it's in the middle of 80 and 100, so that's 90. 90 grams of KBr will dissolve at 65 degrees Celsius. Okay, but that's not the question. The question is asking you how much more will dissolve. All right, so if you know at 65 degrees Celsius, 145 degrees of KNO3 will dissolve, and 90 degrees of KBr will dissolve, all you have to do is simple subtraction. Let me do that real quick. 145 minus 90. So after you do 145 grams minus 90 grams, you'll see that 55 more grams of KNO3 will dissolve at 65 degrees then whoops, this should say KBr of, more grams of KNO3 will dissolve than KBr. Yes, I gotta fix that on your study guide. Okay, describe the relationship between solubility and temperature for KBr. Okay, so look at this KBr graph. As the temperature goes up or increases, the solubility increases as well. So the hotter my solvent gets, the more solute dissolves. All right. So as temperature increases, the solubility of a substance, well, this is asking about KBr, but usually in general, when you make something hotter, more of it will dissolve. All right. How much solute will dissolve at 20 degrees Celsius for NaClO3? All right. Let's use our awesome little strategy. I'm paying attention to my degrees first. 20 degrees. I need this, 20 degrees. It's asking you how much will dissolve from NaClO3. That's this line that I'm going to color yellow, because now I'm going to focus on this line. All right. So let's see if you can do this. 20 degrees Celsius. How much will dissolve? The stops right there. That is a good little dot, so it's right in between 100 and 120, so that's going to be 110 grams. All right, 110 grams. Question 7e. If you add 5 grams of KBr to a 40 degrees Celsius solvent, how much more solute in grams would you need to add for the solution to be saturated? Okay, again, let's take this question apart. What's my temperature I'm paying attention to? 40 degrees Celsius. So I need this one. This is the one I'm going to be paying attention to. This little line over here. And which solute am I looking at? I'm looking at KBr. And this one, this is my orange one. Okay? If I added 5 grams at 40 degrees Celsius, how much more in grams would you need for it to become saturated? So, let's look at this closely. At 40 degrees, in order to reach saturation, KBr has how many grams? You have to look at the very top part of this line, of this orange line. So what is the most of KBr that can dissolve at 40 degrees? Now look at it. So let's see. 40 degrees, KBr, and it's this line. It's very close to 80. In fact, yeah, let's just keep it simple. And yeah, I think it's on the line for 80. So at 40 degrees Celsius, we will say 80 grams would dissolve. All right. So if you added 5 grams, how much more solute in grams would you need it to be added? Okay. At 40 degrees Celsius, we said 80 grams of KBr will dissolve. If you add 5 grams of solute, you need how many more in order for it to be saturated? You need 35, because you did 40 grams minus 5, that's 35. So you need 35 more grams to reach saturation. That means the solvent or the water cannot hold any more of the solute, which is in this case KBr. All right? I know that was kind of a lot, but the whole idea of these graphs is each of these lines tells you how many grams of a solute will dissolve at any given temperature. This is solubility, okay? Each of these is like a white powder. If I just said here are 5 white powders, you can't tell which one is which. But if I took them all and I dissolved them all in 20 degrees Celsius and I saw that one of them dissolved about 110 grams, I know right away, hey, that's NaClO3. All right, it's a characteristic property of matter. Okay, last thing in this video is EDD stuff you should have seen last year in 7th grade, IV, DV, all that good stuff. Okay, I kind of wrote over here what these definitions are. IV is what you are changing, DV is what you are measuring, constants are things that need to stay the same to have a fair experiment, and your title is the effect of the IV on the DV. All right, so does the type of surface, like if I use concrete tile floor or a dirt floor, affect how high a basketball will bounce in centimeters? So the IV, what are we changing? What are we manipulating in this experiment? We are changing the type of surface. Okay, that is what we're manipulating or changing. Okay, concrete, tile floor, and dirt floor, those are called levels of the IV, okay, or the different ways we are changing it, okay. But the IV is, what are you changing? What are you manipulating in this experiment? DV is how you're going to measure it. So read this experiment. How high a basketball will bounce on each of these surfaces. So what are we measuring in here? We're measuring bounce height, right? Because we're trying to see how high they will bounce. Okay, what are some constants we have to have in this experiment? Let's put 2. First thing I can think of right away, make sure you have the same basketball, okay? It doesn't make sense if I have a real basketball for a concrete floor and like a little baby basketball for like a dirt floor. No. Another thing that I would keep the same would probably be if I was taking a basketball and bouncing it on different surfaces, making sure the drop height is the same. Like I'm dropping the basketball from like the same distance from the floor. All right. What instrument do we need to use to measure the bounce height? Okay, I would probably use a meter stick for this one. And the units would probably be centimeters. Okay, second scenario. Does the amount of salt, like 10 grams, 20 grams, 30 grams, added to boiling water have an effect on how long spaghetti takes to cook? In seconds. So, what is the IV? What are we changing in this experiment? The amount of salt. That's the IV. And what are we measuring? How will we measure this IV? How will we measure it? What's our DV? How long spaghetti takes to cook. So, how long spaghetti takes to cook. Okay, some constants we can use. We need 2. I would say we need to make sure we use the same brand of salt. Okay, like we're not going to use Morton for one and generic salt for the other. That doesn't make sense. And also maybe the brand of spaghetti, right? Doesn't make sense if I use like rigatone for one and like gluten-free spaghetti for another. All right. And then what would you use to measure how long it takes? So you can use a stopwatch, okay, and your units are going to be seconds. Last scenario, and then we're done. Does the type of exercise, like swimming, running, or hiking, have an effect on the pulse rate of humans, beats per minute, BPM? So what are we changing? You got it. Type of exercise. That's what we're changing. And then swimming, running, hiking, we call those levels of the IV. In the example before this, 10 grams, 20 grams, and 30 grams were our levels of the IV. And then what is the DV? How are we going to measure the effect of the type of exercise? We're going to measure the pulse rate. Okay, the pulse rate. What are some constants that need to stay the same? We can say things like exercise duration. Would it make sense if you were swimming for 10 minutes and running a half marathon of 13 miles? Obviously, that's a huge difference, right? Another constant we can use is who's counting, right? The beats, the heartbeats, okay? Because if I'm counting them, maybe my sense of hearing might be different from like one of my other friends, you know? And then how can we measure the pulse rate? We can just use, you don't really need like a scientific instrument, but you can use some sort of counter to count how many beats per minute. It's like those counters they use to count how many people on the bus in elementary school. Okay, pick an experiment from above and write a title for it below. Remember, the format for a title is the effect of IV, you put the IV in there, on DV. So let's just do this one, the last one. So you can just say the effect of, plug in your IV, the type of exercise on, okay, so this is the IV, and our DV is pulse rate. Just plug it in. Boom. This is how you write a scientific title. All right. Thank you for studying with me. Good luck on your tests. Make sure you study hard. And yeah, bye.